Today I'm going to make a video on how your blood iron levels can contribute to long COVID. This is going to be my last video in a long series dedicated to long COVID, and then I'm going to wrap it all up, all the science I've been studying on that topic, including what are the recommended tests and treatments for long COVID. Remember, we still don't have actual solution for us to what to do when it comes to long COVID at all, which is one of the reasons why I'm pursuing this science. And the iron levels is a very fascinating story because if I remember everything correctly, then we're going to talk about how low blood iron levels can be contributing to the severity of the COVID-19 disease, how it contributes to long COVID, but also we're going to discuss how prevalent iron deficiency is in the population, how it can also, how lockdowns could have influenced it as well, and even also how it could influence vaccine efficiency if one took a COVID-19 vaccine, and that might have had a factor as to basically how well the vaccine worked for you versus not. And then finally, we're even going to talk about this mystery that I was curious about. Remember, I recently did a video on the use of the vagus nerve neuromodulation, so activation of your vagus nerve, to treat one of the most common and persistent problems related to long COVID, which is your brain fog, as well as in this particular video, it was focused on anxiety and depression via activation of your vagus nerve using your ear and electrical stimulation. And I mentioned in that video that women are more frequently affected than men when it comes to long COVID. And we're going to discuss in relation to iron deficiency as to why that might be. My name is Dr. Mikhail Rashik of Neurogenomics. Let's get going. Again, arm yourself in patience. This is not going to be a short video, I doubt, but let's see how it works out. So first, we're going to talk about the link between iron and your immune system. And the reason why I want to bring this up is because I just want to point out how new this information is. This is something that we're just recently discovering and learning. And this was discovered in only 2016. So it just goes to show you, I keep saying this in numerous of my videos, that we still have enormous gaps of knowledge when it comes to understanding our immune systems and how our immune system will be responding to something as complex as vaccines. And this is one of these gaps, and this is still one of the gaps of knowledge for a lot of healthcare professionals in terms of that relation between, say, your iron blood levels and vaccines. And going back to the 2016 unusual discovery, there was a person who had a mutation, this specific mutation in a protein called transferrin receptor. And this protein, transferrin receptor, its role is to take up transferrin out of circulation, out of the blood, and stick it inside cells, if you can say it like that. Transferrin is a protein in your blood that transfers iron. So this is how iron can be moved about throughout your body via circulation. So what was expected that such a mutation in this transferrin receptor protein would achieve is that it would result in basically iron deficiency anemia. And let me just tell you what anemia is. Anemia is basically when you don't have enough iron in your body so that your bone marrow doesn't have enough iron to start producing hemoglobin. Hemoglobin are the molecules in your red blood cells that carry oxygen. So then if you have anemia, you don't have the proper capacity to move around oxygen, okay? So that would have been expected from that mutation, but instead something completely different was observed. And basically that individual was presenting with severe immunodeficiency. And again, remember, this is only not even a decade ago that this discovery was made. And subsequently, it was then understood. So this was the first discovery, and then it was subsequently understood via further work and further analysis that iron is absolutely necessary for proper immune function and immune responses, and that deficiencies in your iron levels will affect your ability to properly respond or to viral or pathogen infections and your vaccines. So that has already been very well worked out and understood. Let me show you what I'm walking on. Quite a beautiful but treacherous environment. So if I'm very slow, this is why. All right, so that then led to further understanding. All right, iron is needed in proper response to infections, and therefore it was no longer a surprise that iron levels, how good a person might have iron levels, might affect COVID-19. And this indeed has been observed. So what are some of the hallmarks of COVID-19, especially as you go into the more severe situations? So number one that we probably are now all familiar with is hyperinflammation. So this high inflammatory state, right? And that's one of the major hallmarks of COVID-19, right? But there's other hallmarks as well, or other observations can be made. So another one was low blood iron levels. That's referred to as hypothermia. So notice the difference in the two words. I apologize if my accent doesn't allow you to differentiate, but hyper, as in hyperinflammation, means something, hyper means something too much of. Hypo means something too little of. So hypothermia meaning too little iron, in this case in circulation. So that's another observation. And of course, if you have, that's, in other words, hypothermia means iron deficiency, and this is what can lead to anemia, or basically your inability to properly build your blood cells that can carry oxygen. So you'll be starved for oxygen with anemia. And such individuals, COVID-19, they also feature low levels of this protein called transferrin. Now, transferrin itself is a protein that, as I mentioned earlier, will carry iron in your body circulation, okay? So that one, basically, think of like this is in your blood and it moves the iron from one part of the body to another. So transferrin is strictly to transfer iron levels around your body, okay? So COVID-19 patients can present with low levels of that protein. Okay, so another one is, sorry, one moment, high levels of another protein called ferritin. Now, what's that all about? Ferritin is yet another protein. That's the protein that stores iron inside your cells. So it's a storage protein. So once the iron via transferrin is brought to a specific type of cells, this would be, say, either liver, spleen, bone marrow as examples, then these cells can take up that transferrin via transferrin receptor, and it can start storing iron inside those cells, and it uses that protein ferritin to store iron. Now, what's interesting about ferritin is that you can also have some of it in a circulation, and it absolutely correlates with your iron deficiency. So the more ferritin you have in the circulation, in your blood, floating around, the more likely you are to exhibit iron deficiency. So COVID-19 patients had high levels of ferritin, and that's referred to as hyperferritemia. Again, that word hyper, too much of. And the reason why I bring that up as well is because that's the second hallmark of COVID-19 that is very frequently observed in COVID-19 patients. And I'll give you some statistics right away. And the last measurable marker that clinicians would have observed during COVID-19 is too high levels of a protein called, I think it was called hepcidin. Now, what is hepcidin? This is a protein that regulates movement of iron levels from the storage from within cells into the blood. So we talked about how iron can move around blood via transferrin, how it can enter cells and be stored inside cells via ferritin, Now hepcidin can now regulate how the iron can move from the storage into the blood, and we'll talk about that in a second as well. So they also had too high levels of this protein called hepcidin, and again, if you have too much of that protein in your circulation, it will clearly demonstrate that you will not have enough iron in your circulation. Right? So these are the hallmarks. And how frequent is this? So just to give you some of the stats, basically, and based on some of the published literature, 90% of all individuals who were hospitalized would show hypothermia, or basically iron deficiency. And when it comes to patients getting into ICU, they mentioned, in one of the articles I read, mentioned that basically within 3 days of getting into ICU, if the blood markers were measured, then we're talking about like over 70% of these individuals would show low iron levels, too much ferritin, and too little transferrin. So clearly the proper regulation of iron in these individuals is not there. And that is a very common feature. And what has emerged fairly early on is that how little iron an individual had in the circulation tended to correlate with eventual severity of the COVID-19 disease. Now, we'll talk about why this is so important right away. It's because of how prevalent iron deficiency can be in our population. So we'll touch back on that. And basically, the less iron a person had, the more likely they were going to be hospitalized and end up with severe COVID-19. There is a bit of a trick as well, which I'll talk about right away. So it might sound confusing, but basically the take-home message here is that what one of the authors of multiple papers that I studied for this video mentioned, that what could have determined how likely the person was going to end up with severe COVID was their pre-existing levels of iron. Why is this? And it is because of the fact that we actually have a natural response to pathogens that automatically reduces our blood iron levels. The reason why we do this, so that iron is purposely scavenged out of your blood during infection, such as say COVID-19, in order to reduce your blood iron levels, because pathogens are basically dependent on the iron levels in order to replicate and or duplicate themselves and grow. So this is our natural response. This hypothermia, or reducing of your blood iron levels, is also a natural response that we have in order to fight infections, right? And the way this is achieved is via increasing that hepcidin protein levels, the one that regulates transfer of iron from storage into the circulation. So when you have increased levels of hepcidin then starts to degrade, or helps to lead to degradation of another protein. I think it was called ferroportin. So that's a protein that helps to move those iron storage levels from the cells that store iron into the circulation. So when hepcidin increases, that specific protein that's supposed to help move the iron from storage into the circulation is degraded, and you no longer have as much iron in the circulation. And this ferroportin is found in cells such as your liver cells. It's found on macrophages, your immune cells. So why? Because macrophages can actually destroy some of your red blood cells to recirculate iron. And you can see how this is all now linked to the immune system. And they're also found in I believe it was bone marrow cells as well. So with increased levels of hepcidin, we can dramatic and quickly decrease levels of available iron levels, and this way we can fight infection. But there's a price to pay for that, because if this goes too far and too much, then I have to figure out where to go. Then what can happen is basically, in essence, you might not have then enough iron available to you to start producing, not this way, to start producing red blood cells, because there might not be enough iron to produce hemoglobin. So there is that danger. Okay, so we have a natural defense mechanism, and the authors of this publication that I was reading mentioned that very likely this reduced iron levels we see during COVID is that natural response. It happens to many infections, so COVID-19 is simply one of them. So, and this is why they suggested that the severity might be because of what was your iron levels in the first place prior to being infected, and then have that natural response to reduce your iron levels as well. But there's a little kink to all of this. There's a little complication. So let me tell you about that. So what is going on is, I hope I find another path. I want to go further along the beach. There is another thing is that your iron levels, yes, predicted how low your iron levels, yes, predicted the severity of COVID-19 down the road. But you started with low iron levels. If you started with low iron levels, that resulted in mild severity of the COVID-19 disease. Once you started going into severe COVID-19, something else happened, and back again, you would have high iron levels in your circulation. So what is going on? Basically, the authors were saying it's like a U-shaped response. You can start with low iron levels, that leads to a problem, and then you end up with more iron levels, and that leads to further problems. So it's sort of like counterintuitive, because individuals who had no disease basically did not have severe COVID-19 at all. They had normal or high iron levels. Those who ended up with mild severity, they had low iron levels, and those who had very high severe COVID-19, they had again high iron levels. But here we're talking about different type of iron. Here we're talking about iron levels that are no longer bound and transported via your blood, in your blood, via that protein transferrin. We're talking about, in these situations, these individuals had free iron. It's also called catalytic iron. And what's going on is that free iron, or this catalytic iron, if you have that in your blood, it's dangerous, because iron, when it's free and not bound to a protein, either say transferrin or ferritin, it can now help produce reactive oxygen species. And if you've been following my channel and watched my previous videos, you probably would have heard me mention reactive oxygen species can be very dangerous. Why? Precisely because they're so reactive. So they can start reacting with your biological components, and as a consequence, they can start destroying things in your body. It can also be used as a weapon against, for example, pathogens, but if it's dysregulated and there's too much of it, it can start destroying your own tissues, for example, right? So you don't necessarily want to have that free iron in order to start contributing to such an effect. And how do we get there? I gotta admit, I was a little bit hazy on this. I tried to study this and understand this in greater detail, but basically it has to do with the acidity of your blood. So I find it quite fascinating when this concept of the blood acidity. I've heard about this concept many times. Remember, I made a video on one of my biggest nerve videos. I discussed how breathing, which is regulated by your vagus nerve, can influence acidity of your blood. This is also where masking can be really kind of tricky. The reason why is because when you mask, you don't properly breathe and you don't properly exhale carbon dioxide. I made a video on this as well. And as a consequence, you could inadvertently, if you wear a mask too long, increase concentration of carbon dioxide in your blood, and that can result in changing the acidity of your blood. And the point here is that when you change the acidity of your blood, and we're talking about, you don't need to change much. You don't need to think like this is dramatic change. The type of pH of your blood, pH measures the acidity of your blood, is 7.4. Once you start going below that level of 7.4, which is the normal, natural acidity of our blood you want, you can start affecting, basically, I'm giggling because I'm walking in such unusual paths. So like, you can start affecting transference ability to bind iron. And when your blood acidity drops, transferrin will no longer capture iron properly as you would want. I might have walked myself into a dead end again. And you end up with that more of that free iron circulating in the blood. You can now that you have more of the free iron circulating in the blood, remember I just mentioned that free or catalytic iron can start contributing to producing reactive oxygen species, and this can start destroying the tissues, and that might explain some of the observations we might see with more severe COVID-19. There's another element to all of this, and that is there's this natural process that we have, and it's called, I think it's called hypoxia or hypoxic pulmonary vasoconstriction. The name is not that important, to be honest, actually, but the take-home message here is that this is a natural process that basically will constrict certain arteries that bring blood to your lungs under hypoxic conditions, meaning there's not enough oxygen in the blood. And the reason why this happens, it's a natural built-in phenomena, is to restrict blood flow to areas of your lungs that are not ventilating properly, meaning there's no good oxygen exchange there. And instead, when this phenomenon happens, this vasoconstriction, you redirect the blood to the areas of your lungs that will help to get more oxygen into basically your blood. So via this natural process, you can basically help yourself, and this process fails in COVID-19 as well. So it doesn't work properly, and one of the reasons why is because it is also dependent on high levels or it's also dependent not on high levels, it's dependent on iron as well. So, and basically what we're talking about is that could also explain why you have the severity of the disease as well, is because the iron levels, that if they're too high in circulation at some point, they might lead to that failure of that proper response, and you basically end up, you can see there can be like a domino effect where basically you end up as a consequence of less and less oxygen available to an individual, and you end up with having serious issues, right? All right, so that's just COVID-19. Now let's talk about long COVID. Let's jump into long COVID. So with long COVID, obviously, the paper I read when it came to iron levels in long COVID, they talked about that basically about 1/3. See, these statistics change a little bit from paper to paper that I discussed, but this particular paper mentioned that approximately 1/3 of individuals who end up with COVID-19, they end up with long COVID, and those who are hospitalized, that statistic is way worse. It's about 80%. Now this is from memory. I hope I got those numbers correct, but give or take, okay? But it's serious numbers. So the authors who investigated what could be influencing, what are the factors that are most likely to contribute to long COVID. They started over 200 individuals over multiple months, for a long period of multiple months, right? And they studied their immune markers, they looked at their blood markers, they look at their clinical data, and they looked at transcriptomics. If you're wondering what transcriptomics is, it's a fancy schmancy word for investigating what kind of mRNAs your cells produce. And basically, when you look at what kind of mRNAs your cell produces, it gives you a clues what kind of genes a cell is using. Because remember, genes is a storage of information inside your nucleus via DNA, and then different cells will use different genes, okay? And if different cells use different genes, basically the way you can tell which genes are used is by looking at the mRNA. Because if you use a gene, then basically you transcribe it, that's the word for it, and you produce mRNA, and then mRNA is a blueprint that a cell that can then be taken out of the nucleus, and basically it's a blueprint that is used within the cell to produce a specific protein of interest. And proteins are like little robots that do all the work within your cells. Okay, so that's basically when you see which mRNAs are used, that gives you a clue which genes are used. So they looked at all of this. And what was really interesting is that what the factors that were most likely predictive of who's going to end up with long COVID was prolonged inflammation lasting more than 2 weeks, as well as let me show you this. I don't know if you can see where I just walked. So prolonged inflammation, as well as irregular iron usage. So basically that it's referred to as normal regular iron usage is called iron homeostasis. And if it's not working normally, then that's dysregulated. Basically, we're talking about, again, iron deficiency. So prolonged iron deficiency and prolonged hyperinflammation was the most likely predictive factors as to who's going to end up with long COVID, more so than the level of inflammation that an individual could have experienced. So it's not how much inflammation the person had, as much as how long that inflammation might have had in conjunction with inappropriate use of iron. So that is why that might help explain as to why some of the mild COVIDs could still result in long COVID, okay? All right, so then, but there's one more interesting element in that particular study, is that besides low iron levels in the blood contributing to long COVID as well in this circumstance, some cells ended up being loaded with iron. So they had a lot of iron. And remember, when you have very high levels of iron, that basically means that you could be contributing to this reactive oxygen species development. And the cells the authors were mentioning that were impacted were monocytes. So the monocytes, and I just recently did a video on how monocytes could be contributing to long COVID as well. Well, here's an interesting little connection via iron levels, that these, because I talked about how dysregulated function of monocytes have been proposed as a potential contributing factor to long COVID, and how it could be treated by looking at that. And here we are, these authors are also talking about, hey, look, certain monocytes, including the ones I discussed in that previous video, have dysregulated iron levels. They have too much iron levels, and therefore they could run the risk of not being normal anymore because of that reactive oxygen species development via overloading of iron. All right, so that's another interesting connection there via the long COVID. All right, so that's your long COVID connection. I'll talk about treatment at the very end, if I don't forget. I'm very, very prone to forgetting in general. That's basically curse of my life. And what the authors talked about, though, they were ending this particular publication based on symptoms. Look, your iron levels long COVID is known to have known by fatigue, brain fog, pain in the muscles, and technically this is also observed during anemia when you have low iron deficiency as well. So this could help explain these symptoms, for example, and lack of oxygen delivery as a consequence. So for example, muscle pain could be explained by the fact that if you don't deliver enough oxygen into your muscles. It's like heavy workout. Eventually you will start building lactic acid, just like you would do in a workout, because you run out of oxygen during heavy duty workout. But here, if you don't have enough oxygen, you could easily end up with pain in the muscles. So just like one example. And the last thing that they brought up is also the fact that premenopausal women are more likely to have long COVID, and this could be due to iron deficiencies. So that finally brings us to to that topic of, okay, so under what circumstances do we see iron deficiencies in regular population? And this is one of the most common nutritional deficiency in the world, iron deficiency. And basically, we're talking about you're not getting enough iron from, how can you get it? You're not getting either not getting enough iron from your food. So that's number one, right? Number two is, for example, inflammation. So persistent inflammation. So we discussed that. And so that can be, say, during infection, but it could be also during under other circumstances, such as the examples that were mentioned is, imagine hip fracture or colon cancer, right? So then that's another ways you can end up with iron deficiency in your blood. But another one that I will admit I was completely unaware of this is menstruation. Now, this is not a topic of expertise for me. Obviously, I will admit that I am, full disclosure, I am a non-menstruating male, for any of those of you who might have been confused otherwise. So I don't know much about the topic. I made some videos in how the menstruation has been affected in women post-vaccination. So everything I'm gonna tell you was totally new for me. And I wonder how many of you guys who might be watching this video would know what is even the normal volume, blood volume loss during menstruation. I now know, and it's 80 mils or less. Now, however, that's still a lot of blood loss. And basically, when a woman menstruates this volume, this normal volume, that equates to roughly 2 milligrams of iron loss per day. Compared to a man or a non-menstruating woman, which would be similar, is about 1.5 milligrams per day. So eventually, what it means is that a menstruating woman will lose more iron because of that than a man would, or a woman who no longer menstruates. But menstruations can also, they can vary in volume, and they can vary dramatically. Now, what are we talking about dramatically? We're talking about some women can menstruate up to 400 mils of blood. That's a lot. And what does that mean when it comes to understanding iron loss? Basically, in other words, this means that such a woman, when she menstruates this much, she could be losing up to 200 milligrams of iron in a month. And all right, these numbers are potentially meaningless to you, but your average woman has approximately 300 milligrams of that iron available in the storage. So you can see that a woman with a very heavy menstruation could easily deplete majority of her available iron. And it's not that it's easy to necessarily replenish. So, by the way, what are the symptoms of iron deficiency? That's also very interesting, in case, because I don't even know how many women know this. I would assume that women would know this, but you know what? I gotta admit to you, it's not like I ever have a conversation about this with my female friends. So, by the way, what do you do to replenish your iron levels due to your menstruation? Yeah, I know it just doesn't come up in a conversation. So what are the symptoms? So, the symptoms is something like fatigue, poor performance, right? Overall, because you just don't have enough. You don't have enough iron. You don't have enough oxygen. And another one that I remember off the top of my head was, for example, hair loss. That was interesting as well. So there's multiple symptoms that, and I think also maybe like, I hope I'm right about this, like your hands and feet getting cold. But either way, there's like number of symptoms of when you have iron deficiency. And how are you supposed to then, what are you supposed to do in order to help your situation? Well, you're supposed to, ideally, you would want to have appropriate dietary intake of iron. But that ain't easy. And I didn't know this either. So look, we're all learning here. And to replenish those 2 milligrams of iron loss that a menstruating woman experiences, the authors mentioned you would have to eat something like either, for a single day, you would have to eat either something like 200 or 300 grams of fish meat, or eat a kilogram of soybeans, or eat 5 kilograms of spinach. So not necessarily easy. So for those who might not be able to properly replenish their iron levels, you can take supplements. And however, apparently it is not recommended at all to take supplements if you don't have symptoms. If you have your iron levels are low but you don't exhibit symptoms, it is not apparently recommended to take supplements. So I just thought I would share that, what I'm basically studying and reading about this, okay? So then, this is so interesting where I'm walking around. It's like millions of tiny little shelves and steps. Just gotta make sure I don't fall anywhere. And this is even further exacerbated, especially if you're a woman under additional conditions, such as, and this is, at first I was like, oh, what an interesting fact, or this is surprising, such as number one was if you are an athlete. And now that I think about it, okay, that makes sense. Remember, I made this video on beta glucans, helping athletes recover their immune systems. So perhaps this basically means that your immune system is required for your proper function or recovery process post strenuous workouts, okay? And perhaps this could explain why athletic women might be an even further additional situation where they might consider iron supplementation or have appropriate dietary intake of that. And the other one is vegetarians, because as I just told you a moment ago, it's not necessarily easy to replenish your iron levels via vegetarian diet. And that's another, and especially for menstruating women. So I thought I would share all of this with you. And why is that? So this can obviously explain why women are more frequently observed to have long COVID. And this is potentially could be linked to something as simple and potentially so easily controlled as your iron level regulation, all right? So, and that will bring me now to the last few aspects of this, sorry, I apologize, long video, is lockdowns, vaccines, and treatments for long COVID. So, for example, I hope you can hear this. For example, when it comes to lockdowns, there was a paper I read that showed how lockdowns resulted in iron deficiency in some individuals. And the reason why is because lockdowns resulted in dramatic changes in people's dietary patterns and their physical activities. And the authors of that publication mentioned, listen, we should never have lockdowns without proper education of the public on the importance of proper diet that can then properly supplement your iron levels, because subsequently it runs the risk of leading to iron deficiency. So that's one. Now let's talk about vaccines. So one of the agencies, what was it? I think it was called the European Hematologic Association, basically published an expert opinion mentioning that anyone who was taking COVID-19 vaccine should have made sure that their iron levels are at appropriate normal levels prior to taking the vaccine. And this actually points out to as I mentioned at the beginning of the video, the standard knowledge gap when it comes to vaccine use and iron levels. This is something that is missing amongst in the collective knowledge of many of our experts, and that basically, in essence, your iron levels should be made sure to be good and normal anytime you vaccinate. Now, there's a lot of missing information still, because your vaccine efficacy can depend on your iron levels, but not every vaccine is dependent on that. So only some vaccines will have their efficacy of response affected by your iron levels, but not necessarily every single one. And this also might explain why different populations throughout the world might have exhibited different efficacy to vaccines, and that could have been explained simply by what were their iron levels, okay, in their blood. So something as simple as that. But another thing we still don't know is, what is their level of iron deficiency required in order for the vaccine efficacy to be affected? Which vaccines truly are affected? But the authors of that publication mentioned, listen, we should be really paying attention to this, because even slightly increasing vaccine efficacy for some of the vaccines, especially say childhood vaccines, could dramatically influence global mortality. And so that's something well, look, do you remember anyone mentioning this when mass vaccination was starting? Because I don't. Maybe there were some clever people warning us, but I don't remember any of this at all. All right, and then finally, what about in terms of proposed treatments for long COVID? And we're gonna wrap it up here. And wow, I made it to yet another bay, which is very cool. And the authors who basically wrote that paper on long COVID and iron deficiency proposed couple potential treatments. So, well, first of all, they mentioned, look, making sure that you don't succumb to severe depletion of your iron levels due to say COVID-19, or basically your SARS-CoV-2 virus infection, could have been easily influenced by something like having vaccines available. Okay, they were not, so let's skip that. But also proper use of something like antivirals, right? And this might explain, for example, why such countries as India or Peru, and I made a video on this, who heavily promoted use of certain antivirals that shall not be named, might have had such spectacular results. The reason why is because then the individuals who were subsequently infected might not have had such severe iron deficiency loss that as without use of those antivirals. So that's an interesting connection that I didn't think about. And but apart from that, obviously now it's too late. Like that, this is done and over with. They're talking about like what would have been a smart thing to do prior to infection. Now, what about those who have long COVID? And they're talking about a couple of things. Number one is to use those hepcidin inhibitors. So inhibitors that will prevent that elevated levels of hepcidin in the blood. And remember, I was telling you that once you have high levels of hepcidin in your blood, this will result in basically reduce iron levels in your blood, right? So that's something we don't want. So we're trying to avoid that. So that's number one. And the other one they mentioned is interleukin 6 inhibitors. Why that specific inhibitors is because apparently elevated interleukin 6 can lead to elevated hepcidin levels as well. So those are the potential treatments for long COVID that are mentioned here. And this brings us to the end of this rather long video, but you know me, I'd like to wrap up these topics in one go and just complete them. And so, hey, listen, if you like this topic, please give me a like, please share the video. This is how we grow. Leave a comment, and if you are an expert in iron levels as well, teach us some more on that as well in the comments below. And the last thing I'll mention is thanks for your support, and including supporting my Patreon channel, where we publish additional topics as well. And I'll see you next time. Bye, everyone.